Hey, this video is on an introduction to systems of nonlinear equations, which starts on page 301, which is section 7.1. Before we get into nonlinear equations, this video is just a reminder of what systems of linear equations are. I'll give you a quick example. Let's assume that I have a bunch of fence, and my fence, I have a grand total of 32 meters of fence. And if I have 32 meters of fence, I would like to make an enclosure totaling 60 square meters. And I would like my cat to be able to run around in that enclosure of 60 square meters. And because I have only 32 meters of fence, I have to decide on what the length and the width are. So there are two facts that I can derive from this. One is that the length and the width, and I'm just going to draw a little picture here. There we go. Length and width. One's x, one's y. Now I know that because my area is 60 meters squared, x times y equals 60. That's pretty straightforward. The next thing that I know is that x plus y is going to equal 32. In other words, 2x's plus 2y's equals 32. Now I have two equations that model this situation, and this in fact is what's called a linear system of equations because the two equations work together and they are both linear functions. If I were to graph them, I would get straight lines on both of them, and that's why we call them linear functions. So this is a system of linear equations, and to solve it, you would have learned this in Math 8 or Math 9 or something. The easiest way to do it is to substitute it. We'll take this here and we're just going to make y go all by itself, and I'll say y equals 60 over x, and that's quite straightforward. We just divided both sides by x. Once we've got a definition of y, and I'll circle y here in pink, once we've got a definition of y, I can take that y and put it into my other equation. The other equation, which dealt with the same reality, said that 2x plus 2y equals 32. That being the case, this definition of y here, 60 over x, should be able to substitute into the equation where we had y there, and so instead it'll be 2x plus 2 times our new definition of y, 60 over x, equals 32. Now it's just a matter of using our algebra skills to solve for x. We've got a single variable equation. It will end up looking like a quadratic that we can solve through factoring. Well, I'll just show you how to do that very quickly. We multiply every term in this entire equation by x, and we have 2x squared plus 2 times 60 over x. We multiply by x, it becomes 2 times 60, so that's 120, equals 32x. So we've multiplied this and this and this each by x. So this expression here, we can move the 32 over to the other side. We have 2x squared minus 32x plus 120 equals 0. And I can factor the 2 out right away, so we have x squared minus 16x plus 60 equals 0. I just divided both sides by 2. And this one factors. We just have to come up with two numbers that multiply to 60 and add to negative 16, and that's pretty easy. It's minus 6 and minus 10. So x minus 6 times x minus 10 equals 0, and we know from factoring that the two results for x are either 6 or 10, which means that x can be either 6 or 10, and as it turns out, by this logic, if x is 6, then y is 10. If x is 10, then y is 6. So we know that it's going to be 6 times 10. 6 plus 6 is 12, plus 10 is 22, plus 10 is 32, so this equation is true as well. So we solved a system of linear equations through the substitution method by defining a variable all by itself and plugging it into the other equation. Why should it be any different for a nonlinear equation where instead of simple linear equations that make up our system, we have two of those ugly stinking quadratics? That's the subject of a future video.